All right, today we're going to finish solving equations, radical equations, and then we're going to get started with our higher order polynomial expressions. So we solved radicals before when we were in the radical unit. This is very similar to that. With radicals, we squared them. With the cube root ones, we cube them. So there's not a big difference with them. Our goal is still to isolate the radical. So we want to isolate this cube root before we get started. Now, in this first case, it's already isolated, and we actually have two on this one. So in this case, we want to put one on each side of the equal sign. That way, when we cube both sides, the cube root cancels on both sides, freeing my radicand. So 2r minus 6 is equal to 3 plus r. Now we can solve for r just like we do any other equation. So we're going to subtract this r to get it to the other side. That gives me r minus 6 is equal to 3. We're going to add the 6 to get it to the other side, and so that gives us r is equal to 9. All right, we're going to try this next one here. My radical is isolated, so we've got the cube root by itself on this side of the equal sign. So I am ready to go ahead and cube both sides. Now, when I cube this, the cube root and the cube cancel, and we get 3t plus 1 is equal to negative 8. Remember, you can't have a negative here because negative times a negative times a negative gives us a negative. Now we're going to subtract the 1 and divide by 3, and my t is equal to negative 3. All right, right here, again, we're going to cube both sides. We get negative x plus 1 is equal to negative 27. I'm going to subtract the 1, and then it changes the signs on both sides, and we get x equals 28. All right, our fourth one here, the radical is not isolated, so we need to get that cube root by itself. So I need to take care of everything away from it first, so I would add this 2 to get it to the other side. Then I'm going to divide by negative 2. Now we're ready to cube both sides. And so x plus 3 is equal to negative 27. I subtract the 3, and I get negative 30. So that's our solving our cube roots. Again, it's very similar to what we did with our radicals. All right, we're going to get into our higher order polynomials here. When we're working with cubics, that's where we really start talking about the higher order polynomials. And so our polynomials are trinomials and so on, where we've got terms that are raised to a power like this. And so we'll start with the basic operations. In this case, that's adding. When we add polynomials, we are going to add the like terms. So I would add 3x to the fourth plus 2x to the fourth, which gives me 5x to the fourth. Then we have a negative 2x cubed and a positive 5x cubed, which gives us a 3x cubed. Now we're going to do our squared term. This square one has a squared term, this one does not, so it would just be plus 7x squared. Then we've got 9x and negative 4x, which is a positive 5x. And then a negative 4 and a positive 1, which is a negative 3. So we have combined our like terms there. That's basically what you're doing when you're adding. The next one is subtracting. The only thing that makes that a little bit harder is that you do have to recognize this minus is to every single thing in the second parentheses. So I like to start by distributing that negative to everything to really avoid errors. Then we can combine our like terms. So that's what I'm going to do first. I go ahead and I distribute and get negative 3y cubed plus 9y squared minus 4y plus 5. Now we can combine our like terms. So we've got a 4y cubed and a negative 3y cubed, a 2y squared and a 9y squared, which gives us an 11y squared. Then we've got a negative 5y and a negative 4y. That's a negative 9y. And then we've got a negative 7 and a positive 5, which gives us a negative 2. So We distributed the negative sign or the minus sign, and then we combined our like terms like the other one. All right, now we're getting to multiplication. And so a lot of you guys in Algebra 1 learned to multiply with the box. So you can still do this with a box. You would need a box with 2 for this one and a box for 3 with this one. In other words, it would look like that. And so you would have the negative x plus 3 on this side, the negative 3x squared plus 4x plus 6 on this side, and then you're just finding the area of each box, so you're multiplying negative x times negative 3x squared, which would give us a 3x cubed. Negative x times 4x gives us a negative 4x squared. Negative x times 6x gives us a negative 6x. Then we do the 3 and we get a negative 9x squared here. I'm multiplying 3 times negative 3x squared, then 3 times 4x, and then 3 times 6, which is 18. And now you would combine your like terms, and that would be your resulting answer. Now, if you don't want to do a box, you can distribute each one of these terms into the next parentheses. So I would start on this side since there's only 2 of these. So I would distribute the negative x to everything in here. So negative x times negative 3x squared gives us a positive 3x cubed. Negative x times 4x gives us a negative 4x squared. And negative x times 6 gives us a negative 6x. So we've distributed that negative x to everything in the other parentheses. Now we would distribute the 3. And so that gives us negative 9x squared plus 12x plus 18. And then we combine our like terms. And when we write these, we really like to write them in exponential order. So this is the highest degree, the 3, so that's the one I would want to have first. Then I get a negative 4x squared and a negative 9x squared, and that gives us a negative 13x squared. Then a negative 6x and a 12x gives me a 6x. And then we've got a 18. And so we have distributed and combined our like terms. That would be our final answer. All right, when we have 3 parentheses side by side, we're talking about multiplication again. And so in this case, you would want to multiply 2 of them together first, and then multiply it times the third one. So I would pick these 2 to multiply together first and leave my x minus 1 because that's the easier one afterwards. So you can FOIL, basically. 3x times 2x gives me a 6x squared. 3x times negative 3 gives me a negative 9x. Then 2 times 2x gives me a 4x. 2 times negative 3 gives me a negative 6. All of this is being multiplied times the x minus 1. I go ahead and combine my like terms. And so I get a negative 5x in the middle here. And now it's exactly the same as what we did up here. So we're going to distribute that x to everything and then distribute the negative 1. And so I get 6x cubed minus 5x squared minus 6x. I distributed this x to everything in here. Now we're going to distribute this negative 1 to everything in there. So I get negative 6x squared plus 5x plus 6. That gives me 6x cubed. When I combine these 2 together, I get negative 11x squared. Negative 6x and 5x give me a negative x, and then I've got that plus 6 at the end. And so that is multiplication of our higher order polynomials. All right, the next thing we do with polynomials and we did with quadratics was factoring. So we'll start by recalling some of your factoring quadratics, and then we'll move to our higher order polynomial ones. So a lot of the things that we used for quadratics is the same methods we're going to use for our higher order polynomials. To do that, let's recall our factoring. When there is an a value of 1, so there's nothing in front of it right here, then you go straight into your 2 parentheses. X times x gives us this x squared. And then we're looking for what multiplies to be 12 and adds to be negative 8. And so that is negative 6 and negative 2. Negative 6 times negative 2 gives me a positive 12 when I multiply them. Negative 6 minus 2 gives me a negative 8 when I add them. So when the a value is 1, those are the easiest ones to factor. Remember, factoring is undoing that distribution, so we're undoing that multiplication. All right, when there is an a value here, you do have to think of a different method. And so you can use the box, the x, the rooftop, whatever method you use. I use slide and divide. And so that is when I take this 2 and slide it to the end. So that's x squared minus 7x minus 8. So I slid the 2 to the end with multiplication. Then I factor like we did this one here where the a value is 1 because the a value is 1 now. And so I get x minus 8, x plus 1, because negative 8 times 1 gives me a negative 8, and it adds up to be a negative 7. Now, we slid that 2 to the end, so now we need to divide by 2, and so we get x minus 4 and 2x plus 1. And there's our factors. You can always check it by foiling it out and making sure you go back to this right here. All right, this last one has a GCF, so that's what I would have to do first. 10 goes into every single one of those. That's always your first step. If there's a GCF, take that out first. It makes your factoring so much easier. So 10 times x squared gives me 10x squared. 10 times negative 5 gives me negative 50x. And 10 times negative 6 gives me that negative 60. And then now I'm ready to factor. And so I'm looking for what multiplies to be negative 6 and adds to be negative 5, and that is a negative 6 and a positive 1. So that was factoring our quadratics. That was just a quick review for you. Now let's move on to difference of squares, which we also did during the quadratic unit. That's the pattern, and we use this factoring a ton. So if you haven't learned that pattern, make sure that you learn it, because we'll use that a lot. This year, you'll use it a lot again in pre-cal, and you'll use it a lot again in calculus. It tells you if you have a perfect square minus a perfect square, it will always factor to be the first term minus the second term, and then the first term plus the second term. It does have to be minus. If it's plus, it does not factor. So it is a squared minus b squared. What does that look like? It looks like this. This is a perfect square. It is x squared. And this is a perfect square. It is 7 squared. And so we can factor that to be x minus 7, x plus 7. These should be the ones you factor the fastest because they've got that pattern that goes really quickly. Right here, I can see this is 2x being squared, and this is 9 being squared. So 2x minus 9, 2x plus 9. And our last one here, this is 3x, and this is 6. So 3x minus 6, 3x plus 6. All right, this one's just a little bit different because now we've got a higher order polynomial, but like I said, a lot of the methods are the same. This is still a squared term. It's x squared squared, and this is 4 squared. So we can actually write this as x squared minus 4, x squared plus 4. We still had a squared term minus a squared term. Now you need to recognize it again because this is also a squared term minus a squared term. So we can keep factoring that. That is x minus 2, x plus 2, x squared plus 4 does not factor, so it just comes down. So when you want to factor, you keep factoring until you can't factor anymore. All right, so some other ones that work like quadratics are these right here. We've got an x to the 4th term and then an x squared term right here. This factors just like the ones up at the top did. This is an a value of 1, so this would be x squared and x squared in the parentheses instead of just the x. Now, what multiplies to be 14 and adds to be negative 9 would be a negative 7 and a negative 2. And again, you can multiply this out and you'll see that you'll get this back because x squared times x squared gives us the x to the 4th. Then here we get a negative 7x squared and a negative 2x squared, which adds to be that negative 9x squared. And then negative 7 times negative 2 gives you a positive 14. This one's going to factor just like the GCF one. Always take out the GCF first. So I take out my 2. And now I can factor it. By taking out that GCF, I have nothing in front of the x to the 4th, and so it's just like the a values, just like this one here. And so this would be a negative 4 and a positive 2 that multiply to be negative 8, add to be negative 2. And this one would be just like the slide and divide one. So we're going to go ahead and slide that to the end. We factor x squared, x squared. What multiplies to be 30 and adds to be negative 11 is 5 and 6. They both have to be negative because this is negative and this is positive. So a negative 5 times a negative 6 gives me a positive 30. And then they add up to be negative 11. Now we slid the 3, so we need to divide by 3. Since this does not divide evenly, it becomes the coefficient. Since this divide evenly, I just reduce it, and there is my factor form. All right, there's 2 there for you to try, so go ahead and pause the video and give those 2 a try. All right, check your work there. You had one with a GCF and you had one without, and that's what you should have gotten in the factored form. Now we're going to move to some other higher order polynomials, which are a little bit different. Anytime that we factor, we always factor out a GCF. So it tells you to do that first anyway. Regardless of what you're factoring, always factor that GCF. It makes it so much easier and it avoids all kinds of errors. Now that's our step 1. Then we're going to group the first 2 terms and the last 2 terms and factor the GCF out of both of those groups. And then the remaining binomial should be the same for both groups. So here is a higher order polynomial. So we're not dealing with just quadratics. This is a cubic, which is what the unit we're in. We are going to get some that are also to the 4th power. The big thing here is that you see 4 terms. So when you see the 4 terms, you need to think about factoring by grouping. So we group the first 2 terms and the last 2 terms. We're going to factor out our greatest common factor out of each one. You do want it in exponential order when you do that. So 3, 2, 1, and then 0. So make sure that those are in order. X squared comes out of this first one. That's our GCF in the first parenthesis. Now we undo that distribution. So x squared times x would give me that x cubed. And x squared times 6 would give me the 6x squared. Out of the second one, I can factor out a negative 5. Negative 5 times x gives me this negative 5x, and negative 5 times a positive 6 gives me that negative 30. Notice that these 2 came out to be exactly the same thing. So then I factor that out. That can come out of both of these terms. And I'm left with x squared minus 5. And so there is our factored form. Again, if you FOIL that out, you're going to end up with this first term. All right, let's try another one. So I group my first 2 and my last 2. In this first one, I can take out a 2x squared, and I'm left with 6x plus 1. In the second one, I can factor out a negative 5, and I'm left with 6x plus 1. My 2 factors are the same, so I factor that out, and I'm left with 2x squared minus 5. Remember, when we're factoring, you're multiplying this times everything over here, so that gives you this first one. And then you multiply this times everything over there, that gives you this second part. So recognize that's where it's coming from. All right, now group. I can take out an 8x squared here, and I'm left with x minus 8. On this side, I can only take out a 1. It doesn't really have anything else to do. And so 1 times x minus 8 on this one. They are both the same factors, so that comes out, and I'm left with 8x squared plus 1. All right, our last one here has a GCF, so we want to take that out first. 2 goes into all of these. So I factor out my 2. A lot of you guys try and say you divided out the 2, but you did not divide out the 2. There's not an equal sign that you're dividing from on the other side. So you can't just divide the thing by 2 because then you've changed the value of the equation. You are factoring out that 2, so it is still up in the front here. All right, now we group our first 2 and group our last 2 within that parentheses. And so I can take out an x squared, and I'm left with x plus 2. Then I take out a negative 9, and I'm left with x plus 2. Both of those factors are the same, so I'm going to have x plus 2, and I'm left with x squared minus 9. Now, they even tried to trick us on this one because we can go even further here. Since I see an x squared minus 9, I'm not done factoring completely because this is the difference of 2 squares. So we can factor that even further. That factors to be x minus 3, x plus 3. These both are perfect squares. So x squared and 3 squared. So x minus 3, x plus 3. And that would be factored completely. All right, there's 2 for you to try here. Go ahead and pause the video and try those. All right, there you go. See if that's what you got when you factored. They tried to trick you again here. Make sure you're paying attention to see what you need to factor completely. That was a difference of squares, so it factored to be x plus 2, x minus 2. All right, and for our last one, I told you we would get to a point where we got to an x to the fourth as well. So this one is an x to the fourth. Now it's a greatest common factor of x in all of these. So I start by factoring out my x. X times x cubed is x to the fourth. X times negative 4x squared gives us that negative 4x cubed. X times negative x gives me that negative x squared. And x times 4 gives me that 4x. So I factored out that x. Now it's the same as what we did on top. We're going to group. And so I can factor out an x squared, and I'm left with x minus 4 on that first one. On the second one, I can factor out a negative 1, and I'm left with x minus 4. We bring that x minus 4 out since it is in both terms, and I'm left with x squared minus 1. Now, again, difference of squares, recognize that pattern. That's one we use a lot. And so this is a perfect square, and this is a perfect square. That's 1 squared. So I can factor that one more time to be x plus 1, x minus 1. All right, for this one here, again, this is raised to the 4th power. But there's only 3 terms. When you see the 3 terms, that's the factoring like the quadratic stuff. And so this is an a equals 1, so I'm going to go straight into my factors, x squared, looking for what multiplies to be a positive 9 and adds to be a negative 10. And that is a negative 9 and a negative 1. Difference of squares on both of those. So x minus 3, x plus 3, x minus 1, x plus 1. We got a lot of factoring in today.